January the 5th, guys. Good morning. Someone let me know if you're getting audio. I haven't done a live video in a long time. I have to get reused to the software. I would appreciate it if we get in a 5-5 here. And if you can hear me, what we're looking at is the live sat tracker now. It's a link on our website. But again, let me know if you are getting audio. I would appreciate it. Thanks. Thanks, guys. All right, what I want to do is a couple things. We're looking live at this falling Russian rocket. The NORAD numbers are 50505, and they're calling this Persia, or IPM-3 Persia. Okay, thank you, guys. And where it's at right now, again, this is live. You can see it over the southern Pacific Ocean, and this orbit is moving from left to right. It's going to move up through South America. And each orbit, which occurs every 88 minutes, is very close to the one before it, but it's constantly moving. Now, our current altitude is 92.58 miles. At 9:30 this morning, the low pass, and I'm going to explain that with the elliptical orbit diagram, we were at 82.67 miles. And what will happen, and again, if you look to the right there, if you can see my cursor, it says altitude in miles. You can also look at it in kilometers, 148.97 kilometers. This is how high above our planet that this rocket is, 92.55. Re-entry begins on a lot of like satellites or even the space shuttle at around 75.6, I think, miles or 400,000 feet. So we're in a high pass now. I'm going to get to the elliptical orbit, but you can come here, and again, we'll put a direct link in it, and that direct link to this map is in the first video from today. But you're going to see this thing again, 92.5. It just went to 92.49. I'm sorry, this is as large as I can get it on the screen. But it will, if you go there and link up to this, and you can bring it up as large as you need it, but that's as large as I can get it here. Go, maybe put your screen on large. But the last orbit, again, it dropped to 82.67 miles. Each time today, it's going to get a little lower. So when you see it start to get close to that 75, really anything below 80, watch for it to speed up and start a reentry. Now, on this particular tracking map, there's something at the bottom that's not showing here that's showing it says footprint. Click on the footprint, and that gives you this area that this satellite would be broadcasting to, basically. But if you look forward or to the right of this, it would give you a pretty decent idea, say, if this satellite, or excuse me, this Russian rocket started to re-enter at this point, the forward scattering would probably be somewhere in this area. That's going to depend on how quickly it it falls once it starts to get into that reentry and burnout. In other words, if it starts to tumble, it's going to create more friction, and it may slow it down and drop faster. If it comes in sleek and fast and aerodynamic, then it may take longer for it to hit reentry, but then uh, before it hits the earth, and it should scatter. A lot of it should burn up. It's kind of unusual. We've never had a rocket this large do what we're seeing happen now. I mentioned in the video earlier that the nose cone, or what they call the shroud, is missing off the top rocket. Now, was something launched? We don't know. Russia has been silent. They celebrated when it was launched. And then once this happened, and NORAD and other people that were tracking it saw that it was tumbling out of control, Russia became silent as far as I can find out. If somebody has information here about it, let us know. Now, Jennifer, I see what you're saying there, but there's an article that came out, I think it was Fortune magazine, that said that a particular event, which is a delicate situation or a delicate conversation, was delayed yesterday for 2 weeks. I will see if I can link that, but that I do have the link to that in the last video. If you look at the top of the video just before there, I've got the link to the AT&T and Verizon article from yesterday, January the 4th, about a 2-week delay. Did they change it overnight? I don't know. But thank you for asking. But again, look at the video from this morning about this particular Russian satellite. Somewhere near the top, I have the link to that article. And if I can switch over there, I'm kind of, again, this is new. Thank you, Pamela. That's not why I'm doing this, but I appreciate it very much. I don't do many live streams, and I didn't expect that, but thank you very much. But guys, the tracking of this is what I want to talk about. Now, I'm going to try to switch screens again. I haven't done this in several months and not mess this up, but just bear with me a moment. Let's see if I can get this up. Okay, let's see if this will work. Almost there, just bear with me. And what I'm pulling up is a diagram. Kind of decided to do this at the last minute. A lot of people were showing interest in it. But this, let me see what we've got here. If you look to the right, this is what's called an elliptical orbit right here in the top corner. Now, this is representing the Earth and the Sun, but the same thing happens with the satellites, and you can look it up. Some of these diagrams, like this one in the left, are indicating what's an elliptical orbit. In other words, a geostationary satellite like DirecTV or something like that, it's a lower orbit, and it does not have an elliptical orbit like this. But the orbit of this Russian rocket is in this situation. In other words, on the chart that we're watching live, you got a high point and a low point. And the high point indicated here would be at the bottom. You see how the uh, satellites and this particular rocket, it gets close to Earth here, and then it slingshots back out further. That's due to the gravity of the Earth, and they can use some booster rockets if they needed to. A comet does the same thing when it comes around the sun. As it dives close, it gets speeds up, then it's slung further back out into space, out into orbit, and then gets closer. But that's what this rocket is doing. So as we switch back over to the graph, um, what you do is you look at the low point, mark down the time. We've got 88-minute orbits, right? And like I said, at 9:25, and we're very close to approaching a low point at around 11 or so a.m. Central this morning, coming up. But at 82.67, if you want to write this number down, at 9:25 a.m. Central, I did this morning, 82.67 miles high. Then at around 11, start watching the numbers. And let me switch that screen back. Here, let's see what we got. There. Okay, guys. So what we're going to do, again, going back to 9:30, this altitude here that is now 89.77, 76, 75, it's sped up and it's dropping. Now, mark down 82.67 at 9:30 Central, so that would have been about an hour ago. So it's an 88-minute orbit. If if at around 11 a.m. or so, this thing is saying 81 or 80, then you can calculate the rate of drop. So that in the if it's dropping so many feet, then you can kind of calculate how many orbits it will take before it gets to that 75-mile reentry burn-in point. You see what I'm saying? And the low point this morning at 9:30 had us again at about 7 miles above that. So it's not a long time before we reach that point. And again, I'm not saying this thing is going to destroy anything. If it depends on how much debris was involved after burnout into the reentry. and the forward scattering area. If it's in the ocean, then it will be a lot better for everyone. Now, there's questions about the energy source of the satellite. They're saying that some satellites that they launch have a nuclear power plant above them. And I'm skeptical about the shroud being missing from the top of the top rocket there. And did a launch occur? And they're just not saying anything about it because they're saying it was a dummy payload. But think of the millions, possibly billions of dollars to launch the largest rocket around and that far into space. And all the celebrations in Russia, would they really be celebrating the launch of a dummy payload? Or is that to hide embarrassment or hide the truth? Don't know. But if a satellite or another satellite was not launched before this rocket started tumbling out of control, then there's possibility that there is a nuclear power plant. I don't know how large they are, but that allows the satellite to stay up for years along with its solar panels. What would be the effects of that? We haven't seen that this much. So I don't know what will happen there. We do know there's going to be some combustion because of the fuel and the compression of the different ingredients that are in the fuel system of this thing. But this will tell us around when you see this thing starting to get around 75 miles, 76, because it's actually 75.6 miles is the average burn-in point. Then look at where it's at on the map. And if you'll look at this map, you can see it's brighter over South America and North America. That's because we are in daylight. The edges of the map that's shaded, it's nighttime there. So this thing could be visible like the space shuttle was in broad daylight as falling debris. If it's nighttime, it would probably be more visible for obvious reasons. But guys, again, we are now at 87.46 miles in altitude, dropping. The low point again was 82.67 at 9:25 a.m. That would have been a little over an hour ago, hour and 15 minutes or so ago. So we've got the 88-minute mark rising. This thing should drop below the 82.67. That was the low point. I went in and watched it earlier to mark that down. And that's how you have to do this. We've done it sometimes things much higher than this. And we've been doing it for about 10 years if you've watched our channel. But we watched them to where it would take a week or so to do it. And so the reason I waited was because now we're getting into the situation where we will be getting close to re-entry. But again, if you've got any questions about what I was saying here, bring it up in the comments over here. And I'll see if I can answer it. I'm no space expert. I have covered this for a long time, and I do understand a good bit of it, not all of it. But again, if you go to the link, and let me see if I can put that link in these comments. There it is, guys. The bottom of the comments there. I'll throw it up on screen for just a minute, and then I'll get it back out. But this, you notice the 50505 at the end of that link. That is the NORAD designated number for this satellite that they call IPM 3 Persia. But there's the link, and you can go now if you want to, if you can split your screen and check this out. That will take you there. But under this map, you're going to see again a couple of things. You can center the satellite, and that will keep it in the center of your screen, because if you don't, it will drift out to the top or right. Also, you can click the little dot that says footprint. You'll see that red circle, and that's the closest indicator of a forward motion of debris that we have. Of course, that's a pretty large debris field if you look at how large an area of South Africa that red dot covers, right? And again, that forward debris field would depend on if it tumbles in a rough pattern, starts breaking apart more, it's going to fall apart, it's going to drop quicker. If it stays together for a longer period of time, it will travel further before it impacts the ground after the 75 mile, technically 75.6 mile burn-in point. So again, this is science to me. It's very interesting. We don't know what's going to happen with this thing, but for those that are interested in tracking it and all of the other satellites, again, this YN2Y is one of the links on our website. You got Sat Tracker there, and you've got Sat Flare, two links at bpearthwatch.com. But if you don't have the 50505 number, you're going to go to this particular software that has thousands of satellites on it. So if you check this out, and we have other events where we're tracking incoming, or if the space shuttle decided to fall out of the sky, um, then you could track it here with the same method that we're using by tracking the difference in the height above our surface every 88 minutes at the low point. Notice now it is 10:44 a.m. So it's been a little over an hour since the low point was at 82.67. And what you'll notice, guys, if you can see this, is that it will slow down as it gets to that low point because it's about to turn and move back out in that basically a slingshot effect of the elliptical orbit. So as it gets at, again, 84.51, we're watching it. You can say, well, if it goes to 80 or 81 point something, well, every 88 minutes, then it's dropping what? That amount. I'm not sure what it's going to be because I haven't been tracking the other low points today. I just wanted to start at this point, make it quick and simple. So then you say, well, in 88 minutes, again, we've got another possible drop of that much. Now, once it gets into re-entry point, you're going to be dealing with a different speed, a different path as far as forward spread. So we're not sure how that will occur. And a lot of times, once it gets down to that point, there won't be the accurate tracking of impact here. It will continue possibly another few orbits, but you will start looking for headlines and information from the different agencies of, okay, they've spotted the debris coming down here or whatever. But if it's in your area, when you start getting close to the 75, 76 mile an hour, height, I'm not mile per hour, excuse me, miles above Earth in altitude, then you know this thing is getting close to the re-entry point, and you could possibly see the debris fall. If you are going to be checking it out, try to get us some images if it's in your area. And if you've got a YouTube channel or Facebook, put them on there and send us a link. And if we can, we will share them with full credit on our YouTube channel, guys. But again, I'm going to check out your comments here. Um, yeah, it's actually the red dot would be the location where I was at, if that was accurate. Okay, so you can either use a VPN or if you're going to broadcast this, you notice your IP2 location in the bottom right. I have that covered, but I don't live in North Carolina in that area. That's where it's going to show if you're looking from the IP on your computer. That's what that red dot would be. And if you don't want people to know and you're going to do a video, cover up that bottom right corner, right under where it says IP2 location, geolocation, right there. You can cover that up. And that would be a safer thing to do. I'm not really worried about anybody knowing my IP address. I don't have anything to hide. And, I can give and take with the best of them. So, whatever. But just for your information, that's what it is. Um, how do I find them on that item on the website? Are you talking about Voice of Reason, or are you talking about the software we're looking at? If so, let me put that link back in here. I'm not sure if that's what you were asking. There in the comments and on the screen, there's a link of what we're watching. Again, the red dot is DC. Well, more than likely, half of them are in Florida anyway, somewhere where it's warmer with them, out in public, if you know what I mean. Um, Christian B, Russian roulette. That's a good term for this. But guys, we don't know if it's going to do any damage. I've heard people say, mention tsunami. This thing is nowhere large enough to do anything like that. It's just not. But if it were to hit you, then you would know it, or hit your home, or if you want a boat or ship, or, if you look at the airline maps right now at flighttracker.com, it's got to come through that level. We don't know what's going to happen. And because this is not a controlled descent, that makes a big difference. Okay. Like if they're going to take down a satellite after so many years of usefulness, they know some more about what shape the satellite is in and more about the reentry. For instance, this rocket does not have big solar panels to slow it down and then to finally burn off and break off. It's a little more sleek than that, but that will depend on the angle of entry. But again, that's how you would do it. Let's see what we got. We're at 82.26. This is interesting because we are now below the last low pass. If you wrote it down, 88 minutes ago, it was 82.67 miles above the Earth. We are now at 82.19. 818. Now, you'll know when this thing is about to get into that close approach of the Earth and then slingshot back out, because the 82 or whatever number we're at, that point 13, that number will slow down and stop for a few seconds as it starts to reclimb. But each time, that altitude will be lower on both the high point and the low point. And you can mark both down, because in 44 minutes, you'll get the high point. And you can use that in the math if you want to, but the low point keeps it uh, uh, easier to me. 82.02 miles in altitude. It is now over South Africa. It will be in just a few minutes over the Atlantic Ocean and be crossing over, it looks like, our friends in the British Isles up in that area. So um, that will, again, it's going to be important to see what this altitude is. 81.93. So we're almost a mile now lower. So if you're getting a mile per 88-minute orbit, then you've got that many hours, say, to get to 75. But let's wait and see what this says. 81.87. That end number is 86. But notice it's starting to slow just a little bit. But we'll have to just be patient. 81, 83 now. That puts us 6 miles above reentry point. We're now, if this thing goes to 81.67, we know we have at least dropped 1 mile in the last 88-minute orbit. Imagine that you're getting several sunsets a day and sunrises. If you're on the space shuttle, they travel about that same speed. So every 44 minutes, you're going halfway around the planet. We're at 81.75. So if you guys are keeping up with this, again, the last number was 82.67. We're at 8.74. And to me, this is the simplest way to track these objects when they start to fall. If the picture's blurry, guys, check your settings on your YouTube channel. You may be at 220 or 440 as far as the resolution. This is in 720, I believe, and that will help that. Just change your resolution over there. If you got real slow internet, it may buffer on you doing that, but that's what I do if I start seeing it. Sometimes your computer will automatically drop that setting, even if you don't. Okay, we're at 81.69. So at 81.67, we've dropped 1 mile in 88 minutes. There's 6.8. Notice it's slowing down. 81.69. Did it go back? 81.69. So the low point, let me mark that down. Looks like it was 8168. So we were 1/10, or we were at 81.67. So you can basically say a mile. Now it's starting to go back up, 81.69. In 88 minutes from now, mark the time, 10:53 a.m. Central, wherever you're at, mark that. And in 88 minutes, you can check this. So we're basically dropping about a mile per 88 minutes. Somebody over there that's good in math, it's going to have to drop about 5 more miles, 6 miles, in order to get close to that reentry point. So put 6 miles, and then it got 88 minutes to do that. 88 times six. How many hours or minutes is that, guys? Someone come up. I could do it, but someone there can do it a lot easier. 8.8 hours, Jim. So what time? And I in the video earlier, I was thinking that the numbers that they were giving on the chart were a little premature, that it looked like it may take longer. And that's only because I've watched this particular chart for years. And a lot of you have too. Approximately 6.5 hours. May be wrong again. 88 times 6, 88 minutes times 6 miles, or divided by whatever. But so 6.5 hours, about one, two. Anyway, we know what we're dealing with now. If I get my pen out, I'll try to do some of that math myself as we're looking at it. And so at that point, guys, if we'd figure it's 6 to 8 hours, look at this map, look at where it's at, and you may be, if you're in that area, may be able to see some of this re-enter. Depending, it's large, it's still got fuel aboard, things like that. So that's going to be something that it may be something like when, remember the reentry of the space shuttle when we lost those lives. It was very visible, all the different pieces coming in, and it's also kind of a heads up at, about what's going on. 8.5 hours. 8.5 hours from now would be 7:30, somewhere around 7:30 to 8 a.m. Central Time. I mean, yeah, 8 p.m. Central tonight, Central Time. Figure that would be around 7 on the East Coast. And now, what would change was on these numbers. That's why it's good to look at the low point every 88 minutes. Is that it could start dropping quicker the lower it gets, right? You may start seeing 1.5 miles. So those numbers could change. But now you know what you're dealing with on here. It's going back 82.35. So now it's in that long part of that elliptical orbit. It's not a round orbit, and that you're going to see that climb. And if you really want to do it, you could write the high point down and the time, and you can use both of those together. But again, it looks like we will see descent into the burnoff 75-mile altitude this evening. And I've got a couple of things I've got to do. I can't stay here live, but at that point, more than likely, around maybe 6 p.m., 5:30, I'm going to kind of keep an eye on it as I come in and out, and I'll come back live and we'll watch it together if you guys want to do that. Yeah, that would be interesting because I love the comments coming in live here. I don't do this much, but with an event like this, I think it helps a lot. So again, any information you guys are getting, put it up here. Yeah, the orbit is moving right now. It's moving northeast on the orbit. You can see it moving up to the right. And notice the yellow lines that are overlapping. You can go here and go forward in time and look at some of the projections on where the different orbits are, and that's kind of interesting to do too. But it's an estimate, and it does not include the point of impact. It's just where the orbit would be if it was continuing to stay in orbit, which it's not going to do. Well, we really don't know. They're saying it's out of control. Um, who said that? Let's see. Let me go back up just a moment. Things moving fast. In time generation, that we don't know. They're saying it's out of control. It's the things that are concerning me is that they're saying it was a dummy payload, wasn't a big deal. That's too much money and time. If you've seen the pictures of this rocket from the video before this, it's huge. I think it's their largest rocket. And once it starts falling, for them to say dummy payload or whenever they say it, then that just doesn't ring true to me, because money's tight in all the nations. I know that the governments get most of it, and space agencies and all that, but that's a tremendous amount of time and labor and money for a dummy payload. You can, it just doesn't make sense. Doesn't make sense at all to me. I may be totally wrong, but something's not right. You know, with the whole thing, not quite right. I think it could be tumbling out of control now, and they that may have not been on purpose at all. But with the top shroud missing, according to the radar, then something could have been launched out of the top, and so it may be mission accomplished. Someone said earlier that it's not important where it falls, is what some of these space people say. It's just important where it gets to, and where it falls is not important to them. And that's something to think about. But guys, I will again. There's the link on the screen to the exact map that we're looking at. This is going to take you to the NORAD 50505, also called IPM3 Persei, Persei. I think that's Perseus. If someone wants to look closer into that. But right now we're out. It's out over the Atlantic between Africa and North America. See that? Right now, if it was just for instance, the Canary Islands would see this start to dive back into the atmosphere if it was going to do it now. That's where your right side of that footprint is. And as it goes over um, the UK and that area, some of the British Isles, that would be the same thing. But it's going to make possibly 6 more passes around the Earth, 6 more orbits before it gets to the 75-mile burn reentry zone. And that, again, that's an average of different spacecraft and satellites. But guys, I've got some errands I've got to run. I wanted to show you how to do it. Get this link, and I'll put it in the comments also once the video goes. Once it's not live, you'll be up on YouTube, and the comments there will change. But guys, I appreciate it very much. Thank you guys for the donations. You didn't have to do that, but it's always a blessing. Thank you very much for that. I'm going to come back in live. I see Derek, my friend, up there. I'm sorry I can't keep an eye on the comments all the time. God bless you, brother, and God bless everyone that's here. And thank you for everything. We will be back up this afternoon, and we're going to be watching the decay, is what this is called, of this altitude. And we're going to track it. It's a great science lesson, and it's interesting to me, and obviously a lot of you guys are going to be watching it too. It's a heads up. Be safe.